Applications with linear inequalities. The reason we learn mathematics is so that we can use it in different applications. In pre-calculus, we're learning applications that will prepare us to do work in calculus. We have a lot of different techniques for individual type problems, but in general, you want to read your problem to familiarize yourself with what it is you're solving. Make a plan. Sometimes that means set up an equation, define your variables, make a drawing, whatever. Then you follow your plan, and then you check your answer. Here we have a problem that involves a grade, a function that gives us the grade a student makes based on the number of hours they study. The grade g of t a student makes on a test depends on the amount of time t spent studying. The grade is represented by the function g of t equals 4t plus 32. Find how many hours a student must study in order to make a B. Now for this problem, I'm going to use a grading scale where in order to earn a B, you have an average of 80 up to 90. So that means the grade, which is the 4t plus 32, needs to be less than 90, and it needs to be greater than or equal to 80. So this is my plan. My plan is to use my function to set up an equation, or in this case an inequality, to solve. Because it's a compound inequality, I solve it by getting the t by itself in the middle. So I have to subtract the 32 from all three parts. So 80 minus 32 is 48. Then I'll have the 4t in the middle. And the 90 minus the 32 is 58. Now, to get the t by itself, I divide by 4. So this will give me 12 is less than or equal to t is less than, let's see, 4 goes into 58. If you need to, you can get your calculator out to do that. 58 divided by 4 is 14 and a half. So anywhere between 12 hours and 14 and a half hours would give the student a B. Now I could also just look at this and say, well, if a 14 and a half will give him less than 90, if he wants to make an A, well then he would need to study 14 and a half hours or more to get an A on this test. Now if we look at this graphically, you would put the 4x plus 32 in your y1. And then you would set your boundaries as the 80 and the 90 for your y2 and your y3. Let me make this a little bit bigger so you can see it a little bigger, a little better. 4x plus 32 is your function, and we want to know where that function is at least 80 but less than 90. So this is how we would set it up. Now we do have to make sure our window will display these numbers because these are fairly large numbers. So I have chosen to use a window of 0 to 20 for the x's. Because remember, the x is the time the person is spending studying. So they study 0 hours up to 20 hours. That seems like a reasonable number. And then for the y's, I want the y is the grade they make on the test. So I really only care about these grades that are between 80 and 90. So I'm going to set my y's to start at 70 and go up to 100. Then I can set my graph, look at my graph, and I see this point and this point are the two I'm interested in. You can use your intersect function. So let's see, move it to the first curve, to the first intersection is right here. Using side-to-side arrows, move it to the first intersection. Press enter until you get it. It says x equals 12. Then I want to do intersection again. Now, I want to use the first line, so I still use my side-to-side arrows to move up here. But I'm only going to press enter one time because now I need to move my cursor to that second line up here. I want to move it on this line rather than this line because I want to know where this intersects this. So to move it to the other, I use my up arrow or my down arrow. Then I press enter, enter. Wait a minute, I need to move it a little bit. And there's your 14.5. Let me get my calculator smaller. And we'll go to the next problem. Here, I'm given a graph, so I don't have to use my calculator graph anymore. I'm going to use the graph that's given to me for this problem. The blue line represents the cost involved with the yellow cab, and the blue line represents the cost involved for the blue cab. Find the mileage for which the yellow cab costs less than the blue cab. So that means find where the yellow line is below the blue line. So where the yellow line is lower is right here. So this corresponds with mileages of, from here up to here, mileages of 0 to 3. So I would say from 0 up to 3. Now I would not include the 3 here because when the mileage is exactly 3 miles, the cost is the same because that's where my lines are intersecting. For mileages 3 or higher, the cost of the blue cab would be smaller. Now we want to find the mileage that would represent a cost of between $11 and $15 for the yellow cab. So if I see where the 11 is, the 11 goes right here, and the 15 goes right here. So when my yellow line has values between 11 and 15, that corresponds to x values of 5 and x values of 7. So that would be 5 miles up to 7 miles.